Hello class, this is a video lesson for the homework assigned for section 9.4. You were assigned 6 problems, 12 through 22 on page 545. You were supposed to do just the evens. So I'm going to do number 14, then numbers 20 and 22. So I'm going to do half of them and I want to do some of the more harder problems on this section. So we're going to start with problem number 14. This is a pretty simple division. So we're dividing a polynomial by just a monomial. It's a trinomial, fourth degree trinomial being divided into a first degree monomial. So how do you solve this problem? There's two ways. The one that I prefer is to set up a fraction because it's a division and a fraction is technically a division too. So I want to rewrite this as a fraction. So all I've done is I rewrote the problem as a fraction, and I can do that. It doesn't really change anything. So once this happens, I can break up the fraction into 3 different parts. So essentially I can distribute the negative 7s into every single monomial here by distributing the division, so to speak. So this is what happens if I do that. So as you see, I now broke up the problem into 3 different fractions. Again, mathematically I haven't done anything here. I'm just rearranging the problem. But now it makes it a lot simpler to look at each individual fraction and actually work it out. So for example, here I have 21s to the fourth minus 7s. If I look at the constants, 21 divided by negative 7, well, that's super simple. That's just negative 3. And if I look at the variables, the x to the fourth power divided by an s, that is just the difference of powers. They have the same base being divided, so you just subtract 4 minus 1 because there's a hidden 1 next to that bottom or denominator s. So that's just going to give me s to the third power. Then moving on here, again looking at just the constants, I have 49 divided by 7, which gives me just a good old negative 7. So negative 7. And then s to the third divided by s, again, just subtract the exponents, 3 minus 1, s squared. And here, it's going to be minus 35 divided by negative 7, just the constants over here, gives me a positive, a negative 5. It'll end up being a positive because it's a double negative, but I'm not going to write that right now. And s squared divided by s, so you do a subtraction, 2 minus 1, and you get just s. And then I'm just going to make this a little bit cleaner. The double negatives gives a positive here. So that's the answer to number 14. Alright, I'm going to go ahead and move on to number 20 next. Number 20 is not like number 14 because here we are actually going to divide a trinomial by a binomial. So the process is going to be a little bit more difficult. So let me write down the problem. Now I chose this problem for a very specific reason because there are several things going on here that I thought that might be a little bit puzzling to you, maybe a little bit difficult. First thing, none of the polynomials are in standard form, and I need to set them in standard form before I actually do my division. So I'm going to rewrite them in standard form. So q squared plus 8q, so second then first, then 0 degree monomial. And same thing here, the first degree has to go before the 0 degree. Now that that's done, I'm going to go ahead and do my long division. So my divisor, the q plus 7, goes on the outside. My dividend, the q squared plus 8q plus 7 goes on the inside, and my quotient, my answer, is going to be on top of the bracket once I'm done with the division. So now I'm going to look and see what can I do to the q to make it into a q squared. Well, that's simple, just multiply it by a q. So, and I got to multiply the second monomial by the q as well. So q times q, that's q squared. Q times 7, that's a positive 7q. And you're always subtracting in long division. So q squared minus q squared, that's a 0. 8q minus 7q, that's just a good old simple q. And a positive 7 comes down here. So now, looking at this particular problem, I really don't have to do anything. Q plus 7 They're the same thing. So I don't want to change it. And how do I not change a problem? Well, I can multiply it by a 1, a positive one to be specific. So 1 times q, that's q. 1 times 7, that's a 7. So q plus 7. And again, it's a subtraction. It ends up with a 0. And my answer, or the quotient, is just a q plus 1. And how would I check my work? Let's say I want to check my work. Well, you can do that. You take your quotient, my answer, and you multiply it by your divisor, the q plus 7. So you take your quotient, multiply it by the divisor, and you should get your dividend as the answer. If you don't, something went horribly wrong somewhere. So I'm going to FOIL this. Q squared plus 7q plus q, and then plus 7. Simplify. Q squared plus 8q plus 7. And if you look at the standard form of the dividend, they're the same. So check. Number 20 is done correctly. I'm going to move on to number 22 now. Now 22 looks like a simple problem. It looks like a binomial divided by a binomial, and it is. And you might think, well, this should be simpler than a trinomial divided by a binomial. Yes and no. Simpler because there's less numbers, so numerically it's easier. Less simple because in division everything needs to have a place. So let me show you what I mean. I'm going to set this up as a long division real quick. Divisor first. And dividend goes underneath, and this is my dividend. Now I'm going to write the 4y squared first. I'm going to write the negative 5 here. I'm going to leave a space here. The space is there for a placeholder. The reason being is I have a first degree monomial here. No first degree monomials here. And if I put the 5 here, that's actually going to make the division wrong, because the 5 doesn't belong there, not just yet. There needs to be either a nothing there, but an empty space makes some people uncomfortable. So I like to fill it in with a placeholder, a 0y. Doesn't change anything. It's a 0 times y, which is a 0. But I substituted a first degree placeholder that's going to, again, fill in that space and make it less uncomfortable for us to deal with. So that's the only trick to that particular problem. Well, that and the remainder, but we'll get to that. So now I want to solve this problem. So I want this 2y to look like this 4y squared. How can I make a 2y look like a 4y squared? Well, I can multiply it by a 2y. And I got to multiply both. So 2y times 2y, that's 4y squared. Yay. 2y times 5, well, that's 10y. And as always, it's a subtraction. So 4y squared minus 4y squared, that's a 0. 0y minus 10y, that's going to be negative 10y, because again, that negative gets distributed here. So I'm going to bring down this negative 5. So now I have negative 10y minus 5. And I want this to fit in here, or be just like it. So how can I convert a 2y into a negative 10y? I can multiply it, of course, by a negative 5. Now I want a negative 5, not just a 5, because a 5 will give me a positive 10y. I don't want a positive 10y. I want the exact same thing, and I want a negative 10y, so it's got to be a negative 5y. So this gets distributed to both. So negative 5y times 2y is going to give us a negative 10y, exactly as we want it. Negative 5 times positive 5 is going to be a negative 25. And don't forget, it's a subtraction. So negative 10y minus a negative 10y, that's a double negative. It's going to convert this into a positive, so it ends up being as a negative 10y plus a positive 10y, which is a 0. Then a negative 5 minus a negative 25, again a double negative, so that's going to be a positive 20. Okay, great. How can I make this to be this? Well, you can't. This is a 0 degree monomial. This is a first degree monomial. They don't magically grow to become, something else. So that's going to be a remainder. So I'm going to write the 20 over this as a remainder. So it's going to be plus 20 over 2y plus 5. Now, I'm not going to check this problem because checking remainder problems gets a little bit hairy. So I'm just going to not check my answer. I'm going to hope that I did it well on the quiz. Your problem that you will have to check your answer will not be a remainder problem. So you won't have to worry about that. You'll be able to be freely checking your problem. So, but I'm fairly confident that that's the answer. So, yeah, that's the homework problems, at least half of them done, and the tough ones. So if you have any additional questions, I'll be back on Friday. We will go over this homework. This is when it's due. And thank you.